Hi everyone, welcome to the OpenSensors webcast. We're going to spend some time today talking about the three key technical aspects that people should be wary of in deploying sensors. During this webinar, we're going to stick to anything outside of cloud. So we're going to talk about the sensors, the kind of networks and so forth. Just be aware that the data processing and so forth side is going to be left to another session. So to kick things off, my name is Yodit. I run OpenSensors. My colleagues, Lawrence, who's a solutions architect at OpenSensors, and Kevin, who handles the service delivery side, presents some information that a lot of people ask about. So we'll cover the types of sensors, focusing mainly on utilization sensors, talk about how they work, ideal configuration of the network within a building, and really kind of some know-how around deployment. So I'm going to go straight into it. We're going to focus on utilization sensors. And what we mean by that is specifically three, I suppose, distinct types of utilization sensors. There's desk and phone booth sensors, which tell you is somebody present on a desk, within a phone booth, and so forth. These are PIR motion sensors, battery powered. The expectation of a battery life is between 2 to 3 years within kind of the networks that we design. There's also meeting room presence sensors. These focus on understanding within a room, is somebody present or not. The third type of utilization sensors is people counters. These go within either meeting rooms, breakout areas, or kind of open spaces. These are ceiling mounted, mains powered. They rely on object recognition and they count people in one direction or another. One of the biggest things to be aware of in terms of the types of networks we're focusing on is accuracy. We do this in two ways. We do it focusing on the field of focus, both for the PIR and counting sensors, as well as categorizing what presence actually means. So if you think about it, your normal PIR sensor that you would have in your building would have a very wide field of focus. It would turn on the lights as you enter a room and so forth. Within a desk, you're talking about kind of meter by half a meter rectangle that needs to be covered. So the field of focus is much, much narrower. You have to categorize presence as being somebody sitting at a desk for at least 10 minutes in our view. And what you're trying to do there in terms of accuracy is you're minimizing false positives. You're trying to ensure that, for example, the person across the desk on the other side, their legs aren't picked up as presence. Anyone walking behind a desk is not categorized as a presence either. Another question we get a lot is, do you need a sensor for each desk? And the answer to that is not necessarily. It depends on the outcome that you're trying to get to. So for agile style working areas, you might need kind of very granular data on a desk by desk basis. But for a lot of people, what they can get away with is actually what they want is the high level utilization numbers. So 50% coverage desks, for example, enables you to extrapolate good enough data for a high level utilization number. We tested this. We could get plus or minus 5% accuracy or confidence accuracy with a 50% coverage. Other people move sensors around. So they take sensors they do a time-bound study, do one floor, move the sensors to another floor after a period of time, and so on and so forth. So there's many ways to shape these deployments based on the end outcome that people desire. Just going back to specifically around the meeting room counters, these are really good for when you're trying to answer the question, which is my meeting room right size? So I have a meeting room for 8 people. The number of people that is designed for using it on a regular basis. And for most people, kind of really the crux of it, the questions that they need to answer. And over a period of time, you can see, the kind of average occupants for this particular meeting room, for example, on average, 3 people use it. Sporadically, it's actually full. So then people can start making trade-off decisions around whether they should have smaller size meeting rooms. People counters is footfall sensors, and these are usually around trying to understand in an open area, either in hallways or specific areas, the number of people coming in and out of these spaces. So you're getting kind of bi-directional data count, how many people have gone into the lifts, how many people have gone out the lifts, what are the trends in terms of timelines, mornings versus evenings, and so forth. Lawrence is going to talk about the ideal network required for all buildings.
Wireless sensor networks have been deployed in buildings for getting on for 20 odd years now. The fairly early incarnations of those were something like a wireless thermostat talking to the HVAC system controls the heating and cooling inside the building. And they typically used a very simple point-to-point solution. And about 10 years ago, we saw the emergence of something called mesh networks, which were designed to overcome the range issue you have when using RF communication inside a built environment. And then about 3 to 4 years ago, we started to see the emergence of a technology called LPWAN, which stands for Low Powered Wide Area Networks. And what these provide are long battery life, good range, and a very, very simple deployment method, and also lower cost. And as a result of that, we're now starting to see wide-scale deployment of sensor networks, such for occupancy, environmental monitoring, and increasingly now for service on demand. One of the main considerations when we're looking at a building is how do we get signals reliably from our sensors to gateways and then onto our product platform. One of the terms you may hear RF people talk about is something called path loss, and all that simply means is what happens to the single signal from a sensor to a gateway, and what obstructions appear between that. That can be human beings, that could be walls, that could be desks, filing cabinets, whatever you find inside the built environment. So one of the things when you're using high frequency technologies such as Bluetooth or Wi-Fi, your propagation inside a building is vastly reduced. That's why, depending on the region and the world you're in, we use lower frequency devices which have much better range or much lower path loss inside a built environment. And what's more is we don't use mesh networks because they actually require maintenance to design a system such that a signal gets from one node on the network to the next node to the next node. We use a simple star configuration, which basically means either a gateway per floor or a gateway per 2 floors, which will serve hundreds of sensors. It's a much simpler system, easier to install and much easier to operate. It might seem like a strange title to actually use, but it's part of a set of principles. Our primary aim is to ensure that we have a robust and reliable system. So the first thing we do is we segregate. We means we don't run on the corporate IT network. We ensure our sensors don't interfere or are affected by existing systems. We're separate. We don't provide a means onto the corporate network, which can be and has been exploited by third-party WAN access. And siloed. Siloed is much more a concept. It's saying, right, treat your IoT devices differently. Don't treat them with the same sort of IT security policies you would do with a PC. IoT devices have certainly hit the headlines big time for breaches. And this has mainly occurred with consumer IoT devices. So one of our principles is if you can, do not use an IP address for a sensor. In our case, our sensors don't actually talk IP, they talk an RF technology, so they're separate again. And as with any good security practice, you need to authenticate. So you need to know, is that sensor on your network one of yours? Is that gateway on your network one of yours? Also, you need to ensure that you actually have end-to-end security for your devices. So that means your sensor uses AES encryption and your gateways use TSL security, and as part of that, you actively need to manage the keys in your sensor and the certificates on your gateways, and that needs to be part of good security practice and clear InfoSec processes. And as I said earlier, we've seen the emergence of a range of different LPWAN technologies. We've been using LoRa now for nigh on 3 years, and there are a number of reasons why we've used LoRa, and in particular LoRaWAN. LoRa is the RF component of our solution. It stands for long range, and typically people have been reaching many tens of kilometers outdoors from what we call point to point. But what this means in terms of the built environment is that we get exceptionally good performance inside a building. That means that we have far less infrastructure. As I said before, that means it's cheaper and easier to install, maintain. LoRa is an open standard, which basically means that different manufacturers can create devices that sit on a network, and these will fully interoperate. We exploit that. We use a range of sensors from different manufacturers. LoRa networks can be both public and private. By public, we mean a system operated by Vodafone or 3 or any of the network operators around the world. We operate a private network, which means that we have full control from the sensor through the gateway onto the internet or a on-premises server. And finally, LoRaWAN provides the key requirement of end-to-end device security.
So one of the things that we found, at least using our years of collective experience in deploying IT and IoT into the kind of built environment, is really that it takes a multidisciplinary team to actually deploy and scale these networks. And I think there's a lot of complexity involved in not only kind of building these networks, but how you manage them. One thing that we've done, and kind of our typical kind of approach with these projects, is to pull together a multidisciplinary team on our end and try to align that with some of the in-house expertise that a client might have, from IT to the kind of senior stakeholders, etc. But at least in terms of our end, from kind of mitigating risk, we find that having teams with diverse sets of skills really is what it kind of takes to really kind of bring together this technology and to kind of realize it in the workplace. So one of the things that we kind of tend to do, we have an overarching project manager or program manager, and then 2 subsets of teams. One that's really kind of focused on managing the hardware, and a lot of this kind of goes into the logistics. So when we're talking of delivering hundreds of sensors into a building, we need to manage that logistical process, as well as the installation process. We have a very defined set of workflows that we embark upon for each installation. Some of the network design kind of challenges, things that Lawrence has touched upon from earlier. Then separately, as collaborative team, at least something that we approach collaboratively with looking at the technology, is then bringing in the engineering experience from the team, as well as looking at how we can pull the data together and making it coherent for the end user. That way it's for hundreds of potentially messages that we might get from each node or from each sensor per hour or per day, that all of that is easy for the end user to then understand. And that then is something that also takes into account some of the hardware testing that we do within the team as well. We tend to kind of focus our projects into 3 distinct phases. And so we kind of approach phase 1 as a kind of prepare phase. And this is where we aim to kind of bring together all of the stakeholders and align the technical objectives that we have for the technology with the kind of KPIs that the business or the client has for looking at utilization within their building. And one of the main things that we do within this prepare phase is then start to look at the site survey, how we can coordinate any site-specific changes that might need to be made. These tend to be mostly along the lines of where the gateways might be positioned. And because of the nature of how we build our networks, most of them are wireless. So for the sensors, there's not really much of any site-specific changes that needs to be made there. The only changes that need to be made is just planning for things like power. So for some of the ceiling-mounted sensors for footfall that we might use, we obviously want to make sure that they have power, that power is on continuously and it's free from interruption or any kind of outages during kind of working hours. So making those kinds of plans into part of the project plan. Then also, as part of that site survey, we're also looking at the different layers of the network within the building. So from the sensors, how they kind of communicate to the gateway, and also from the gateway to our servers. And much as Lawrence had touched on before, we have a completely segregated system that doesn't kind of touch the human network or the in-building existing network for each one of our clients, but managing each stage in that networking process, from how that sensor generates its message and ultimately how that message is received at our end and presented visually in the dashboards. All of those kind of considerations need to be mapped out in a way where we can not only ensure that data comes through reliably, but also if there is any kind of potential developing issues, we're alert to those to be able to resolve them before they become bigger or critical to the project. So one thing we do at this prepare stage as well that helps to kind of lower the risk within each project is to actually spend some time actually hardware testing each kind of configuration that we're putting into the building. So feeding on from the site survey and learning as much as we can about the site potential challenges, we also spend a period of time soak testing the hardware to make sure that it meets our standards, but also at the same time that we know that when we get to site, it's easy for us to roll out, as well as the scale, and then to manage the actual hardware as an ongoing asset management process. So all of this, we spend time at office staging the hardware and then actually delivering that. But typically this can kind of turn around within a week to 2 weeks. So it's not a long-term process, but at least just allows us to lower the barrier and potential risks proceeding to the next stage without being fully prepared to embark on deployment. So one thing when we come to actually deploying each network within a building, the one added advantage in spending so much time at least kind of planning out for potential risks and obstacles is it makes our deploy time much more rapid. Is each one of our kits that we ship out to clients is pre-configured, is packed, everything is asset tracked from not only the actual assets being shipped, but on our system, we can also match those assets to physical locations on the project as we map them in real time. So a great thing that then allows us to do is to unpack and potentially have hundreds of sensors going live in hours, potentially, as well as all of that actually gathering data in real time. Because we haven't got to wait for someone else within the organization to allow us to patch in or to have data coming out. As soon as we bring a sensor live, the data from that sensor is then feeding through to the project, so we can get near instant insights into utilization that we're looking for as we deploy. One of the things that we do as well is setting up each of our clients for multi-channel support. We've found a number of deployments that we've done in this space that having an easy avenue to not only monitor and asset track the health of the network, but also being able to support our users to be able to use that network is a key a key requirement there. So being able to be reached by phone, by email, as well as live web chat really allows us to have a collaborative way of working, not only in conjunction from a technological sense with the client, but also to help them actually understand the data coming through as well. Following on from this is then we start actually looking at some of the data coming through. In that, if we then start to look at the customer success plan for each client, then we start to align a lot of the vision that we had and discussed in the initial kickoff meeting with some of the objectives and some of the data insights that we get from each one of the projects. So one of the things that we spend time with each client doing is actually gathering that data for them, helping them to make sense of that data, looking for those patterns and insights, and then helping them with an onboarding process to then understand how they can better that for themselves. One thing that we also do is, and also actually is found as a risk in these kinds of deployments, is not having like complete stakeholder alignment. So one thing that what we mean by that is to have all of the kind of end users kind of involved in the process. So one of the things that we try and do is to hold workshops, both remotely as well as on site, to bring other users within the office to give them some context about what this technology is about, to alleviate some of the risks that they might have about it being in their workplace. A lot of people might not be familiar with having sensors under their desks or knowing what they're there for. So you try to hold and to try and do this in a more open manner, where we can actually have that discussion about what benefits this technology will bring for them as users of their offices, but also in terms of what this will allow for in a more agile or open office environment to make their facilities much more better managed and more pleasant for them as employees. So as the last piece, and just actually evaluating some of the data that we spend, that we've kind of gathered, we spend a bit of time with each client in ongoing kind of monthly or quarterly reviews with each client, actually qualifying the insights of what we have from the data, and also helping to kind of shape how they might coordinate those changes within their office. So if they're finding that occupancy is too high or too low, or that a meeting room is possibly too big, or they might want to change different locations for desks, for example, if they're trying to manage that as a change management process. We also try and make sure that we align that with our own internal processes for how we're managing the project as well. So a key part of how we do that is we have asset management kind of built into the product, so we can easily manage and track where each sensor is tied to a physical location. But then within any changes that each client might want to make about how the office is laid out. We obviously have a way to update those floor plans and to manage that process so that everything stays in sync. So one last thing we see as a kind of a key requirement is to try and keep all stakeholders aligned, from not only from the technology side, from the people that are managing the technology, the people that might be using the technology, but also for the end users within the office, to give them a sense of what benefits it brings to them, and also to kind of alleviate any fears that they may have about a new technology being introduced that they're not completely aware of.
The key takeaways, if you think of it as the kind of the local network of sensors, I think utilization sensors have become a broad term. The appropriate sensors need to fit the use case, and thinking through and aligning these is hugely important. You know, not just the kind of the type of sensor, but the amount and the density of the deployment is really dependent on the use case. Network considerations, we use wireless sensor network. We've seen quite a bit people trying to use, for example, powered desk sensors and so forth. And the biggest problem we see with this is that people unplug them constantly. So battery powered, especially when it's near people, is very important. Mains powered for the ceiling sensors and so forth makes sense. Mains and PoE, I use that term, but mains powered, but PoE is also possible. And Lawrence has touched on the RF considerations and security. I'm going to start taking questions. Please flag up any questions. There's a few that we've got already. I'm going to go to Kevin first. What is the ongoing maintenance required for a network?
Yes, a good question. As far as ongoing maintenance, I think it really depends on how you're set up to kind of manage it. I think when you're installing hundreds, potentially thousands of individual sensors across different levels of a building, you really need to have a process by which to know of how that network is operating in real time. So I think one thing that we spent a lot of time building into our product is a real-time monitoring solution that gives us essentially real-time data and operational data from each sensor and the gateway, as well as from the cellular network. And I think if you look at each level of the network, whether that's locally between the sensor and its gateway, or wider between the gateway and the cloud, each one of those parts of the network needs to be managed. And as far as the ongoing maintenance part of that is really just understanding how each one of your nodes or each sensor is operating. And so one thing that we have built into our product is device monitoring. So we get real-time alerts if a sensor, for example, hasn't sent us a message over a given period of time. We also get messages or alerts based on battery level or changes in the network, for example. So if we have any outage or any degradation in terms of signal to noise gets too high, then we get that as a generated message that allows us to then be proactive in some sense, as well as reactive to any kind of changes that are happening. But one thing that is probably the easiest way of kind of ensuring that data comes through reliably, consistency, is trying to be as proactive as possible. So really interrogating your network constantly. We do that daily with checks on each network that we have in place, checking the health of each sensor, checking each gateway. It's a laborious task, but I think if you plan it and you have some strategy around it, it then becomes something that you can automate quite easily. And we've built a number of tools to allow us to do that.
Thanks, Kevin. Next question is, how quickly is sensor technologies developing? Will sensors I buy today still work in 3 years' time?
Without doubt, the sensors that we're currently deploying will be working. I will have seen them quite easily working for a good decade. In terms of sensor development, what you're typically relying on is actually the thing that does the measurement. So one technology we're looking at the moment for an enhanced meeting room uses a sensor that basically has a grid of 16 cells, and that gives us a heat profile. And what that does is effectively allows us to have a low cost but simple way of actually getting seated occupancy. One of the challenges around using something like a PIR is that you need a degree of movement. And the other sorts of technologies we're starting to see is possibly the use of Doppler radar type technology for people counting. This allows us to actually use battery technology for certain use cases, which again reduce cost, makes life easier to install. So predominantly we're dependent on the actual development of sensor technology, not necessarily the RF technology, which, as far as I'm concerned, in our choice of LoRaWAN, this will probably be one of the key global standards for the next 10, 15, 20 years.
Thanks, Lawrence. Following on from that, I just have another question. It says, can any sensor join the network? The answer is yes. Utilization sensors are the most common within an office environment, I would say. What people do, I think, is to kind of go through a maturity cycle from personal observation. They put in utilization sensors, then they start thinking about employee well-being, and then they looking at environmental sensors, noise sensors, and specifically, or air quality sensors. And yes, people kind of just then add layers of complexity to the networks. And a lot of these networks, the design is to be future-proof so that it can be extended. You can add more gateways or more sensing capabilities as necessary. Thank you very much, everyone, for joining us. We try to do these every 2 or 3 months. If there's anything that we haven't covered, please send it my way and we'll get you at least a written answer. Really appreciate your time. Enjoy the rest of your Monday. Thank you.